Hello students, in previous lecture we have learned about the solid states and the types of solids, that is crystalline solids and amorphous solids, and the few properties of solids, that is polymorphous solids, isomorphous solids, as well as anisotropy and isotropy of the given solid substances. Then in previous lecture I have discussed with you that every crystalline substance, it is made up of different types of crystal structures, and about 14 types of crystal structures are there, which is also known as unit cells of that crystal lattice. Then according to this concept, crystalline substances are of different types. Then one more classification of crystalline substances. Today we are going to study about that. Then see here, I have already discussed with you that the basic constituent of crystalline substance, atoms or molecules, or it is a charged particles, and those charged particles, it may be cations or anions or both cation and anions. Then according to this concept we can classify the crystalline substances in 4 types, that is in 4 categories. That means that classification of crystalline substance is depends upon the type of basic constituent present in that crystal lattice. Then first one, that is ionic crystals or ionic solids, or it is also known as ionic crystals. Then see here, focus on the name of that type of crystalline solid, that is ionic solid. That means here basic constituent of this solid is ions. That means see here, basic constituent of ionic solids are ions. That means it may be, that is cations and anions both. It is cations and anions both, or it is also known as charged particles, and charged particles are nothing but these are cation and anions. All of you studied about that cations and anions. For example, NaCl, that is common salt, of which basic constituents are Na plus and Cl minus, which is present in the crystal lattice of NaCl, and the crystal lattice of NaCl is of cubic type structure, or cubic lattice structure is there, in which those cations and anions both are present in the cubic crystal lattice of NaCl. All of you studied about that in previous lecture. Similarly, few examples of ionic solids or ionic crystals are there. That is, see here, K2SO4, CaF2, Li, Br, are the few examples of ionic solids. Then we will discuss about the properties of ionic crystals. Then any ionic crystalline substance of which basic constituent is charged ions, that is cation and anions. Then see here, there are oppositely charged ions are there. Therefore, there is each ions are bonded by Coulomb force to other ions, that is which is surrounded to it. That means Na plus that cation which is bonded with Cl minus ion by Coulomb force, that is electrostatic force of attraction between charged, oppositely charged ions, that is in cation and anion. Then few more properties of ionic substances, that is they are hard but brittle. See here, when shear force is given on the ionic crystals, they can be split into small crystalline particles. Here common salt, the large crystal of common salt, when pressure is given on it, then it can be converted into small particles. That means it is a brittle. It is hard but brittle. And next, that is they have high melting point. Melting point of those substances are highest. It is because of electrostatic force of attraction is strongest in the oppositely charged ions, that is basic constituents of ionic crystals. And about 600 degrees Celsius to 3000 degrees Celsius melting points of ionic crystals are there. They are also poor conductor of electricity in their pure state, that is in their solid state. That means when they are in solid state, they cannot conduct electricity through it. But if that solid substance, if those solid particles when get melted, it is heated, and when that get melted, that means that molten ionic substance in their molten state, that is fused molten substance of those ionic crystals are good conductor of electricity. It is because of when they get melted, then those ions which is present in the solid crystals, they dissociate into Na plus and Cl minus ions, and those ions are now free to carry the electricity through that molten state of ionic crystals. As well as when those ionic crystal, that is common salt, if it is dissolved in aqueous medium, that means aqueous solution of NaCl, for example, common salt, aqueous solution of common salt, then they dissociate into Na plus and Cl minus ions. And aqueous solution of ionic crystals and fused state of that ionic crystals, they are also good conductor of electricity. That means, see here, they are good conductor of electricity in their molten state as well as in aqueous medium. And examples of those that are common salt: KCl, potassium chloride, lithium bromide, calcium fluoride, CaF2, that is K2SO4, potassium sulfate. Those, see here, second one type of crystalline substances, that is covalent solids or covalent crystalline substances, or it is also known as network crystals. Then the basic constituent of covalent crystals is atoms. Then see here, there are three-dimensional network is formed of covalent bonding between atoms of that substance, and which forms a giant network. That means, for example, diamond. All of you studied about that diamond, the structure of diamond, that is each carbon particle is surrounded tetrahedrally. See here, that is the tetrahedral structure of diamond crystal. See here, each carbon atom is surrounded by other 4 carbon atoms by covalent bonding in tetrahedral geometry, and it forms the giant networking. That is the structure of diamond, and that three-dimensional network of those covalent crystals are known as, these are also known as giant molecules. It forms the giant molecules. That entire crystal is a single molecule. It is because of strong network formation takes place because of covalent bond is there, and covalent bond is strongest bond. Therefore, that structure, giant structure of that crystalline substance, which makes it hardest. That means, for example, diamond, all of you studied the giant network of that diamond. See here, in which there is a three-dimensional network which forms the giant molecule. Diamond is the hardest material or substance, and as they are hardest, they have high melting point, about 1200 degrees Celsius to 4000 degrees Celsius, or mobile electrons are absent in those giant network of crystalline substances. Therefore, they are poor conductor of electricity. Poor conductor of electricity as well as thermal conductivity. They are poor conductor of thermal conductivity. That means they are poor conductor of electricity as well as heat. That means here it is because of absence of free electrons, the crystal structure of those crystalline substances. The few examples of that covalent or network crystals, that is here quartz, that is reti, quartz, which is nothing but it is a SiO2, silicon dioxide, as well as diamond, graphite are the few examples of those network crystals, as well as carborundum and boron nitride are the examples of that type of, that is covalent or network crystals. Then the next one, that is metallic crystals or metallic substances or metallic solids are there. See here, in metallic crystals, the basic constituent of those solids are atoms. These are atoms of same metals. That means these type of solids are formed because of atoms of the same metals. Then the metallic bonding is present in that type of crystalline substance. Then what is metallic bonding? Then see here, if it is a part of that metal and metal is made up of atoms. For example, see here, if it is made up of that is copper atoms, then those metal atoms in which valence electrons are there in their valence orbitals, then metal have tendency to lose electrons. Therefore, those electrons delocalized into the interstitial space which is present in that crystal structure. Then those electrons becomes free to move. Therefore, these electrons are known as free electrons, or those are known as mobile electrons. Here in solid metal, these delocalized electrons are present in entire crystal of that substance, and then positively charged particles of metal atoms are called as kernels, and there is attraction between, bonding between that free electrons, mobile electrons and kernel is called as metallic bond. And see here, in metallic crystal, those positively charged ions of metal which floated in the sea of that mobile electron, that means there are lot of free electrons are there, and it looks like that those positively charged particles are get floated in the sea of free electrons, and the bonding between mobile electron and those kernel is called as metallic bonds, and that type of bonds is present in all type of metals, that is sodium, potassium, copper, nickel, zinc, Au, Ag, etc. In all metallic bonding are there. Then all of you have aware of that metals are good conductor of electricity and heat, because there are lot of free mobile electrons are there, and because of those electrons they are good conductor of electricity as well as thermal conductivity. Then those substances, that is metals, are malleable. Malleable, that means it is hammered, they are converted into thin sheets, that means into like that sheets, and that is the malleable property. They are also ductile in nature. Ductility, that is the property of metal, that means we can draw the wires from that metals. All of you have aware of that different types of wires are there. Electrical wires which is made up of copper or zinc, or different types of alloys are there, and that is the property of metal, that is ductility, that means wires can be drawn from those metals. Then they are also hard, few of them are soft. Sodium is soft, as well as mercury is in liquid state, which is also soft in nature, but most of them are hard and they have high melting point. Their melting point is about minus 39 degrees Celsius to about 3400 degrees Celsius. That means the substance, the metals which are soft, which having low melting point, they have also negative melting point. And the substance, the metals which are hardest and having high melting point, they have nearly about the 3400 degrees Celsius melting point. That is about the metallic substances. All of you have studied about that metals in previous standard also. Then see here, fourth one type of crystalline solid, that is molecular solid. Molecular solids are there. Then see here, the basic constituent of those crystalline solids are molecules. Or see here, if monoatomic substances are there, monoatomic solids are there, then their basic constituent is also atoms. For example, argon, neon, like inert gases are there. At room temperature they are gaseous instead, but when pressure is given on those gases, those can be converted into liquid as well as solid. Then solid form of solid argon and solid form of neon, which are monoatomic solids. Their basic constituent is atoms, and the main basic constituent of those molecular solid is molecules. CH4, H2, ice, that is water, H2O, HCl, HF are the few examples of molecular solid in which their basic constituent is molecules as well as unbonded atoms are there. I have already discussed with you that examples of molecular solid. The basic constituent of those are molecules as well as in monoatomic molecules those are atoms. See here, methane, carbon dioxide, H2, Cl2, those are in gaseous state, but on solidification they gives the molecular solid, and the bonding in those type of solid is covalent bonding. Covalent type of bonding is there in those type of crystalline substances. There are different types of molecular solids are there. See here, there are few solids, molecular solid, in which there is weak dipole-dipole interactions are there. For example, HCl, SO2 and that is water. Dipole, all of you studied in 11th standard. That is, for example, HCl molecule in which H atom and Cl atom which contains covalent bond, as that Cl possesses partial negative charge while hydrogen possesses partial negative charge. Therefore, HCl molecule is polar in nature. That is, it is because of those shared electron pairs shifted towards more electronegative atom. Therefore, that HCl molecule, which is a dipole, HCl, that is dipole molecule, and between dipole-dipole interactions are there, and all of you have studied about that. Those type of substances which having permanent dipole moment, that dipole moment which is denoted by mu, that dipoles which having the dipole moment, that mu which is measured by the formula, that is Q into L. Q means the charge which is measured in Coulomb. There are partial positive charge and partial negative charge on the poles of that dipole, that is measured in Coulomb. That charge which is measured in Coulomb into the distance between that dipoles, the distance between that dipole, that is the length, that is the L, denoted by L, and the product of charge of that polar molecules measured in Coulomb and the distance between those poles is the dipole moment of that substance. All of you have studied in 11th standard about the dipole moments and dipole-dipole interaction. Then see here, it is one of the type of molecular solid in which weak dipole-dipole interactions are there, because here the negative pole of this dipole molecule is attracted towards positive pole of the next molecule. Then one more type of interaction is there, that is the molecular solid which having van der Waals forces, or it is also known as dispersion forces, also known as London forces. London forces. Then see here, for example, CH4, H2, that is solid methane molecule, solid hydrogen molecule, which are non-polar in nature. Non-polar, that means poles are not there, but in HCl or in SO2 or H2O, in H2O, that is, see here, H2O is also dipole because hydrogen possesses partial positive charge while oxygen possesses partial negative charge, and therefore it is a dipole. Water is a dipolar in nature. But here in methane, that carbon atom is bonded with 4 hydrogen atom by covalent bonding, and here see here, the electron negativity of carbon and hydrogen is same, therefore the shared electron pair between those cannot be shifted towards, cannot be shifted towards any one of the atom. Therefore here poles are not developed in CH1. All organic substances, that is organic substances, all of you have studied in 11th standard. Most of the organic substances are non-polar substances. That means here solid methane gas, solid hydrogen gas, that is non-polar molecules are there. And between those molecules, see here, there is interaction between those non-polar covalently bonded molecule is London forces. See here, that is CH4, one of the molecule. The second molecule of CH4, methane, solid methane, CH4. See here, there is a weak interaction between molecules. Intermolecular interaction is weak, and it is known as van der Waals forces. That means in non-polar molecules, there is van der Waals forces or London forces are there. That means see here, those are the examples of molecular solid which contains van der Waals forces. Then third one type of molecular solid, that is here the molecular solid which contains intermolecular hydrogen bonding. For example, see here, that is ice, that is H2O, ice, in which intermolecular hydrogen bonding is there. NH3, that is ammonia, and HF, the solid form of those substances in which intermolecular hydrogen type of bonding is there. For example, NH3. See here, NH3 molecule. See here, one of the NH3 molecule in which hydrogen possesses positive pole while nitrogen possesses negative pole. And here the another molecule of ammonia, see here, which possesses hydrogen, in which possesses fractional positive charge on it, and nitrogen possesses fractional negative charge on it. Then third one molecule, that is of ammonia, which is also dipolar in nature. Then see here, it is the first molecule of ammonia, second molecule of ammonia, and third molecule of ammonia. Then negative pole of nitrogen of this molecule, it attracted towards the positive pole of hydrogen. Similarly, the negative pole of second molecule of ammonia, it attracted towards the positive pole of third molecule of ammonia, and that is the intermolecular hydrogen bonding are there. Those type of examples we have already studied in 11th standard. That means, see here, molecular solids of which basic constituent is molecule, or in monoatomic substances it is of unbonded atoms are there. Then there are three types of interactions are there in different types of molecular solids, and the interaction between those molecules is of covalent bonding is there, and which contains three types of interactions are there, that is weak dipole-dipole interaction, as well as intermolecular hydrogen bonding, as well as London forces or dispersion forces are present in the molecular solids. And here we have studied about those different types of crystalline solid in this lecture. See here in your textbook, the chart of the different properties of 4 types of crystalline solids are given in this chart. See here, according to those properties, we can distinguish between the different types of crystalline substances. See here, ionic solid, molecular solids, covalent solids or network solids, as well as metallic solids are there. The properties of those substances are given here. Then you should solve the exercise which is based on those properties of different types of crystalline solids from your textbook. Then in next lecture we will discussing about the unit cells and their different types present in the crystal structure of solid substances. Thank you.